exploding. And I guess everybody here is aware or owns a bunch of IoT devices that can either travel with them and we need this international cellular connectivity. But we also see that a lot of IoT verticals actually choose simplicity in terms of management, and they like the idea of pre-provisioning their devices from one connectivity provider and deploying them all over the world using this new product that we've been hearing about, at least a lot in the telco sector, the global IoT SIM. Now, what are some of these things that sort of depend on mobile roaming, you might ask? So some of these devices are, devices that actually move like connected cars. But we also have devices that don't move, are stationary. However, their connection is pre-provisioned and it is actually roaming. That means that these devices, such as connected coffee vending machines or connected points of sale, smart meters, energy meters, wearables, and so on, they come with a pre-provisioned SIM card. So they connect to an operator. They have a card provisioned by an operator that is not native to the country where they actually operate. So in this sense, this is what we mean by IoT devices, things that are in roaming. And this managed connectivity trends are actually forcing, in a sense, the repurposing of all this ecosystem that for the past tens of years has been developed and designed specifically for people. So we do see that the force and the explosion of IoT is repurposing all this ecosystem and brings to the center of our attention the needs of these verticals. And the IoT providers actually do focus on providing the verticals with connectivity, reliability, and performance guarantees globally. However, given this information, I had personally very sort of blurry understanding of how the ecosystem allows us to do this. Like, what makes roaming possible was the first question that came to my mind. Like, how do mobile networks actually interconnect? What type of infrastructure they depend on? So this is how I basically dived into the analysis of the IP exchange network and try to understand its role and how it's built, who forms it. And because this network is not natively part or visible to publicly to measurements end-to-end from the public internet, to understand how an IP exchange provider operates, essentially what I chose to do was to take the point of view of an operational IPX provider, just to try to get a sense of what the traffic sort of was that was flowing through this infrastructure, this IPX network that was connecting all mobile network operators. And I mentioned that a major point here is that, IoT and the way, sort of the importance that mobile roaming is getting these days sort of shifts the way that different entities use the ecosystem. So one major question was, do we observe new players appearing in this ecosystem? And the answer is yes. And we identified two major new models of operating IoT platforms and mobile network aggregators, which we sort of started to characterize and try to also identify some of their limitations in terms of operations. And these are some of the questions I'm going to touch upon during the talk today. I left, I'm not going to go deep in all of them because we don't have that much time. But I did leave you the references in case you want to dive a little bit deeper in any of these questions. However, I'm going to, quickly go through points 1 and 2, and then dive a little bit deeper and try to understand a bit better mobile network aggregators specifically and how the ecosystem is changing and then just open the discussion to some of the limitations that we were able to find and some of the open questions that we are, struggling and trying to answer now, which I guess it's the most interesting part. So, this is obviously not work I do by myself. I have a lot of support from wonderful colleagues who I would like to acknowledge here. So this is joint work with all these great people that you see listed here. So yeah, let's have a look at, what makes roaming possible. And just to set sort of the terminology so everybody's kind of on the same page, I'm just gonna discuss what international roaming is in a nutshell and what does it entail. So basically, when we talk about international roaming, we talk about two roaming partners that are two mobile network operators, usually a home mobile network operator, which you see in the left side, and a visited mobile network operator, which you see on the right side in the blue. Now, in order to talk to each other and to establish an agreement, they need to have a way to connect, right? And the way they achieve this is by plugging into a hub, a roaming hub, which is also called an IPX provider, an IP exchange provider. Now, these IP exchange providers, there are several in the world, and they are all connected in a full mesh. Now, each mobile network operator out of the, 800 plus that we have worldwide will have a service agreement with at least one IPX provider. So they will pay the service charge to an IPX provider, essentially to increase their footprint internationally. Now, with this in place, the visited MNO, the VMNO, and the home operator, the HMNO, are able to talk to each other and establish a roaming agreement. So what does this mean? Basically, it means that the VMNO is able to tell the HMNO how much they are expected to be paid in order to give service to the HMNO's clients and users. So when this is all in place, what happens is that end users from the HMNO become inbound roamers to the VMNO's network. And from the other perspective, the VMNO basically has outbound roamers that can go and connect to any other network worldwide. Right, so these are sort of some of the basic terminology we're going to be using moving forward. Now, the ecosystem that basically allows this, the IP exchange ecosystem, has at its core this IP exchange network. So the IP exchange network we found is made up of a little more than 30 IP exchange providers. So these IP exchange providers are connected in a full mesh, either through private peering or using peering points that offer this specific IPX exchange interconnection service. So AMSIX, for example, is one. And this IPX network essentially interconnects all mobile network operators across the world, and not only them, but also other type of service providers like CDNs, fixed networks, ISPs, and so on. Now, one major characteristic of this IPX ecosystem that I just described is that it's completely opaque from the public internet. So if I were to measure end to end, actually, I wouldn't be able to collect any meaningful information about this ecosystem. Now, essentially, the main function of this IPX network is to build pipes of communication between roaming partners, and to then set up tunnels of communication so that the data between the end users and their other endpoint of communication can flow, right? When we're talking about these tunnels of communication and these pipes for data roaming, these basically depend on the configuration for international roaming that roaming partners actually have in place. And we have three main options. So when a user basically travels from the HMNO to the VMNO and connects there, the exit point to the public internet can have roughly 3 choices in terms of its location. So it could be located actually in the VMNO network. So this is called local breakout roaming. It could be located somewhere, so it could be passed on, externalized to the IPX provider, to the IPX network, and it could be located somewhere between the HMNO and the VMNO. So this is called IPX breakout. Or it could go all the way back to the HMNO and exit through the home country. So this is called home routed roaming. Based on some private past information that we collected through measurements, we actually found that home routed roaming is the status quo right now. So it's the solution that is mostly in place and preferred by all mobile network operators worldwide. Now, to study this ecosystem, because it's so hard to get a look from the public internet, what we did is actually take samples from within this platform. So we sampled the routing table of one IPX-P to try to understand, whether indeed or how dense this interconnection would be between IPX-Ps in the IPX network. So we actually found, by looking at one of these private routing tables, was that majority of service providers, like more than 80% of service providers, so again, this could be MNOs, CDNs, and so on, have only one IPX provider. And actually, there are very few, there are a small number of IPX providers that connect many of the service providers. So this is probably a property that is not so extraordinary, but it is interesting to see that there are some very popular IPX providers out there. Okay. However, in order to understand a little bit more how the traffic looks like that actually flows through this IPX network, what we chose to do is actually take a view from an operational IPX provider. So we decided to sample an IPX provider that incidentally we operate as Telefonica, of course. So we basically sampled the infrastructure that this telco provider operates on top of their global infrastructure. So the IPX network is essentially taking advantage, and it's built as a virtual overlay on top of this global network footprint. And what we did is actually build a data collector that samples the major signaling points of the IPX-P's infrastructure. And we focused on sampling signaling traffic that corresponds to both 4G and 2G, 3G communications. We focus specifically on data roaming services. However, we only look at establishing the tunnels of communication and not the traffic that actually flows through these tunnels. And we also sampled the resources specifically allocated to IoT providers. Right, so the data set essentially is made up of these 3 major, let's say, parts. The signaling information to just establish the communication, as we were discussing before, the actual information, the control information to set up the communication tunnel once the agreement is in place, and then the same thing as above, but for IoT devices. And when analyzing this information, the first thing we asked was, okay, what can we say about the mobility patterns of the devices? Now, if we look at the devices in a specific visited country, which in these mobility matrices you see on the vertical, so each row corresponds to a visited country, can we actually check where these devices in each visited country get their connectivity from? So can we actually verify, this diversity and the need of this pre-provisioned connectivity that we were discussing, or the trend of the digital nomads. So indeed, we see that there are two major hubs of mobility standing out, essentially the UK and the US. And we did this exercise both pre-pandemic in December 2019 and post-pandemic, or during the pandemic, in July 2020. So we see that the same mobility hubs kind of stand out. And essentially this validates what we were saying at the beginning, where, you know, a lot of people and things are sort of moving and using connections foreign to the country where they actually are active. So this basically captures the movement of people, and we see that this analysis, for example, can capture this mobility patterns of digital nomads, in this case also immigration between different countries. So because of the way the infrastructure of our telco is deployed, we captured the activity across the Venezuela-Colombia border, which is one of the most active borders in the world. So this is the picture of December 2019, showing that our data set is actually able to validate and to show us this trend of digital nomads and in this case, migration. Not only that, but we were also able to separate the IoT devices. And we were looking for a 2 weeks period, which you have on the x-axis on the upper side, at just the number of users active during a specific number of days. So we see that for smartphones on the left-hand side, you have, a large number of users, of end user devices active for 14 days. However, for IoT on the right-hand side, you see several order of magnitude larger number of devices active for this 14 days. So this actually tells us that there is a trend for IoT devices to operate in the so-called permanent roaming. So that means that the IoT application purchasing the IoT managed service actually decides and also deploys these devices that operate all the time in roaming. So the service is continuous, let's say, in roaming. So this may not be a problem. However, we see that this translates into much more signaling traffic being hauled through all this IPX network from IoT devices. So essentially what we did is compare the time series of the signaling traffic for 2G and 3G in the upper part. So you have on the x-axis your timestamp, and on the y-axis just the volume of signaling messages. And just by visually comparing the red area, which corresponds to IoT, the green area, which corresponds to smartphones, you can see that there is much more signaling traffic corresponding to IoT devices generated by IoT devices than smartphones. And this is true also in 4G, right? So this may be an issue because this traffic actually is basically transferred for free. So the payment between the visitor network and the home network only happens when you actually build a communication tunnel and you use it by transferring actual data. So the signaling traffic always flows for free. However, it does put a lot of stress on the IPX provider network. So they cause the so-called signaling storms, especially when you have like billions of devices like smart meters that are synchronized to send one packet all at the same time. So that creates basically a signaling storm. So now we have seen that with this analysis of of the ecosystem, we can capture, the patterns of digital nomads, but all the movements of digital nomads, but also the patterns of connectivity for IoT verticals. And we have seen that IoT verticals actually are pushing for permanent roaming, and they're much more stressful for the ecosystem, which basically kind of opened the conversation around how should we treat these new players, how should we build them, and of course, this is always the tricky part, like how should we define what is now being called wholesale roaming as opposed to normal charging of a user in roaming. And this conversation has been pushed also by the fact that the ecosystem now has, nurtured new types of entities that serve the needs of IoT applications, such as specifically IoT platforms and mobile network aggregators. I'm going to quickly describe the whole idea of how they operate. Essentially, IoT platforms. I think I lost you. No, you're still hearing me, right? Yeah. Okay.
Yeah, we can hear you.
Okay. Sorry about it. So for IoT platforms, essentially they leverage the whole ecosystem to run sort of take advantage of different radio access networks across the world, but run with a single core. So they depend on a single home network, let's say, and they leverage the roaming agreements of this one home network to deploy devices worldwide. So essentially, if you think about it, we have an end-to-end platform that would depend on this home MNO or this IoT SIM provider. So this home operator will be the one that will assign an IMSI range to the IoT devices, and will connect through roaming partnerships in multiple countries, different types of devices of IoT verticals, which we discussed at the beginning, from like connected cars, connected points of sale, smart meters, and so on. Now, these IoT verticals, the applications have a commercial agreement with the IoT platform, and they get access to some sort of management dashboard where they can manage these devices and establish the connection of their devices to the IoT vertical application servers. Now, this roaming partnership is essentially what I explained at the beginning, right? So usually IoT platforms depend on one single home network, much in the same way as an MVNO would, right? So if you think of the model of an MVNO, this is pretty much what an IoT platform does, but specifically dedicated to IoT verticals. So one example, for example, is smart meters, which I'm sure you're well aware of. We found, interestingly, in the UK, that many of the smart meters deployed in the UK actually depend on SIM cards from an operator in the Netherlands. And we're not talking like 10 or 20, we're talking about a few millions of these devices, right? So this is an important trend. Now, a new type of player is actually the mobile network aggregator. Now, if the IoT platform depended on only one base MNO, what we found is that MNAs actually are able to aggregate multiple base MNOs depending on where the end user actually operates from, wants to connect to, right? And we have essentially different flavors of MNAs, much in the same way that we have different flavors of MVNOs/IoT platforms. So we're going to have light mobile network aggregators that just focus on the sales part. So they just manage the sales part, and they use the core and radio networks of different external networks, or full MNAs that choose to run their own core and then, establish their own roaming agreements and use the radio networks of multiple networks of other partners across the world. Now, you might ask me, so what are some of these MNAs? Like, are they operational? Can we use them? And the answer is yes. And we were very interested to understand if indeed there is any improvement in terms of performance from using this latter model. So some of the commercial MNAs that you might have heard of are Google Fi, which is a light MNA. In the US, they aggregate T-Mobile, Sprint, US Cellular, and in the EU, they switch to 3UK. That one is their partner. Another one that we looked at was Truephone, which is also a light MNA. So Truephone operates in 8 different countries where they have, well, it operates worldwide, but it has agreements with base MNOs in 8 different countries. For example, in Spain, it operates over Orange, and in the UK, it operates over, I think, still Virgin Media O2 until the end of the month. Another example is Twilio, which is a full MNA. They run their own core in AWS. They specifically target their service to IoT devices. And in the US, for example, they also have a version where they can use as a base MNO T-Mobile. Now, what we did to understand if there is actually a performance, increase from using this MNAs, we bought SIM cards from these commercial MNAs, but we also tried to compare them with some of the baselines in each of the countries where we measured. And I'm just gonna refer here to some measurements we did in Spain. So in Spain, we bought Orange as a baseline. And because we were measuring Google Fi, and Google Fi in Europe uses 3, we also got a SIM card from 3. And then for Twilio, we used both products, the Super SIM, which is their running their own core, their own mobile network code, but also the wireless SIM, which is basically using T-Mobile. And we just decided to run some web performance measurements. We chose 4 targets that are served by servers in different locations. So we have UCLA.edu in the US, URL.edu in Europe, UC Louvain in Belgium, MIT.edu that is served over a CDN. And we measured the page load time for these web pages. And you can see in the table here in the right-hand side, basically the different configurations. So I'm going to start from the bottom and go up. 3net, which is one of the baselines, Orange, Twilio Super SIM, Truephone, and then Google Fi over 3, and also Google Fi has the option of switching on and off the VPN service. So we chose to test Fi over 3 with no VPN, Fi over 3 with VPN, and then Fi over T-Mobile with and without VPN. And you can see also from previous traceroute measurements we ran, you can see in the breakout column, the point of breakout to the public internet for all these configurations. And this is important because it will allow us to interpret the measurements for the page load time. So essentially what we found for the baseline in Orange, right? We found that when the breakout point is in the US and I'm trying to access web pages that are in Europe, obviously I'm going to see high penalties, right? However, for Fi over 3, right, so for Google Fi, in Europe. So that means that it switched to a base MNO that is 3 in the UK and without VPN. And also for TruePhone, we have actually a close performance to the baseline. So we do see that in this case, the MNAs, these two MNAs in these configurations are actually pretty good at being close to me going to a country and buying a local SIM card. And another takeaway here is that you might look at the red bar, which corresponds to the measurements for the CDN case, is that the low delay in CDN actually does not eliminate the impact of the different configurations. So although it's overall better, it does not solve the problem, right? So this is just to give you an idea of some of the work we've done. And I'm just gonna discuss now some of the open questions that we are dealing with and some of the work we are doing in this space. Now, one of the major questions is when we are discussing the MNA model, what improvements and what limitations were we able to identify and what sort of solutions we are working on? What improvements can we bring to the current MNA model that we see out there? Especially in terms of which are the best networks that I could aggregate? Where is the optimal location of the core network functions that I could have given this model of operation? And essentially, because now in 5G, we basically have this opportunity of separating the control and user plane, we thought to, test this out and keep the control plane at home and just move the user plane where the actual user is traveling, is connecting. And you're going to ask me why. Why are you going to do that? Well, the control plane usually stays at home. And this is a requirement from the billing side. And essentially, this is what also motivates the home routed roaming. So we see so much home routed roaming, even for MNAs, for these new players that we have in the space, because the billing is always the same. So the billing means that the home network and the visited network sort of want to have a view of how much traffic, both want to have a view of how much traffic the roaming user exchanged in the visited country, and then are able to compare these counters and, pay up, right? So this is how it's been done since the beginning, and it's very, very hard to change. So one workaround that we thought was, okay, let's keep the control plane in the home country, and then I'm just gonna move around the UPF where the user travels. So we actually tested this in a scenario where we basically had a device provisioned, let's say, by a UK-based core network. And this device, we moved it to the US or in Germany. And we did the same measurements as before. So page load time towards the same target websites. And basically what changed from the previous case is that we were able to select now the UPF breakout point. So by changing the UPF location, we changed basically the breakout point. So we no longer have those breakout points in the table, but we have a breakout point that you see in this table here. So for UK, we chose a breakout point in the edge or, in a random operator, in a random location. In the US, again, we changed, we placed the UPF in the edge, local or regional. So different locations within the AWS infrastructure. And then in Germany was the same. So we basically shifted and changed the location of the UPF. And depending on these configurations, basically we saw that performance may improve in some cases, but it really does highly depend on the cloud infrastructure availability and the cloud infrastructure performance itself that we actually use you know, proof of concept, let's call it, right? So this is still work in progress, and we are still you know, trying to find here an intelligent solution, an optimal solution. Now, again, the major problem and why we brought this work around initially was the fact that there seems to be this inherent lack of trust between the visited network and the home network. And unfortunately, even right now, we see that if in 5G, even when we're talking about wholesale billing, which we were mentioning at the beginning, this lack of trust remains. And the models, the new models of charging, do not bring a solution to that. So even if local breakout is possible and it's optimal, it's not being used because both networks want to have a view of the activity of the end user. So the hard question here is, how do we change that? What solutions do we have there? And, you know, there are a bunch of other open questions, such as, you know, what are the privacy requirements of this ecosystem? How can we detect anomalies within this ecosystem, given that IoT is becoming critical infrastructure? And how we can do a smart resource allocation for this type of new players that we see emerging. And with this, I'll leave it here, and I'll give you what the reference is, and I'll thank you for indulging me, for paying attention so long to this talk. I leave you with the references. I encourage you to have a deeper look here, and I'm opening for questions. And thank you so much.
Thanks, Andra. So I will open up the floor for questions. I have a basic one while people are thinking of questions. Maybe I missed this. How do you figure out whether a device is an IoT device or an actual phone handset? Do you probably only have the SIM ID, right? From that, is that possible to figure out what the UE is?
We do have the APN information. Usually that gives a little bit more information. And then we actually look at the email of the device, which basically allows us to separate the TAC. And then using the GSMA TAC database, we are able to see whether some devices are actually IoT devices. However, if we're only seeing like it's a Android device, a smartphone, we look at the APN and we are able to reverse engineer from the APN string what those devices might be used for. So if we see like IoT or M2M or like a specific brand name that might be using that, or a specific business name that appears in the APN, that tells us that it might be an IoT device. It's not perfect, it's a heuristic. And this is actually an open problem, because what we have found in our, I'm just gonna maybe go to this part. What we have found when we were analyzing IoT platforms is that for visited network, this is completely unknown. So if you're a visited network, you're just going to give service to the devices asking for connectivity. And if you have a roaming agreement in place, you're going to actually honor that roaming agreement, right? But you don't know if it's an IoT device or if it's an actual person. This was basically the reason why wholesale roaming conversation started, because there were so many devices in roaming, and for the visited network, there was not a possibility to sort of immediately detect them. So you do have the APNs that kind of gives you some idea, but inbound roamers can be anything. So yeah, we have this IMC 20 work that we published was basically presenting the heuristic and how many of these devices, how prevalent this phenomenon is. So we basically showed that 20% of the population actually are inbound roamers that are IoT devices using this heuristic. Yeah.
Cool, thanks.
No, thank you. Thanks.
Andra, thank you for the talk. I had a quick question. Oh, sorry, Dimitris, I think that I have jumped over you. I didn't raise my hand, just started talking.
That's okay. Carry on, Ignacio. I'll go next.
I was wondering if you had seen specific places or actors that are trying new billing methods to overcome these limitations that you were mentioning.
I mean, there is a conversation now ongoing CGPP about the wholesale billing models in place. So 5G basically opened the door to IoT wholesale. So now we do see a separate conversation for IoT platforms and for MVNOs. That's basically, focus on giving service to IoT. However, that does not solve the problem of this home routed necessity that we see. So if, essentially they're just able to separate now devices, but the ways, the fundamental underlying way you do the accounting for the bytes and so on, it's basically the same. We have been working in this space for a few years now on building some solutions to allow for interaction between mobile network operators without trust. So we were actually thinking, like, how do we authenticate a device? Because that's essentially what is required, right? So when I have a device connecting to an unknown network, a visiting network, immediately the visiting network will ask the home operator, who is this device? Is it yours? Is it okay? Is it safe? Can I give access to this device to my network? So can we remove all this control conversation? And to remove it, what would we require? So, like, do we still need an IMSI in a post 5G era? Can we replace this? And what would that, do we need that authentication that is so tied to the home network? Or can we use some sort of global identifier and basically decouple the user from its home? So a user might not have a home. So we are working on some of these futuristic sort of models that scare operators and especially business departments. But allowing for interaction without trust is the way to tackle sort of this billing problem. Yeah. I don't know if I confused you or I answered your problem. Feel free to follow up. I may have confused you more.
Discover the underlying complexity of why that is a problem, and it does not have a straightforward solution.
Yeah, I mean, whenever is money in the game, that's always very, very challenging. And it was shocking to me to learn that, 20 years after we defined roaming, we're still doing the same work. You're measuring in a file, I'm measuring in a file, we're sending it to the same third party, and they're actually comparing the files, and then they send you a bill. So it's shocking. I was like, wow, 2022, and we're still doing it like that. I mean, before they were doing it in suitcases, now we're just transferring files. So I guess some progress. Yeah. More questions?
Yeah, very interesting. Can I go on? So very interesting, and some of these challenges were a headache back in the mobile IP days. Can I ask you, Andra? I'm trying to understand conceptually what is the correlation between mobility and crossing country boundaries, other than the pricing model. In the sense, you could have mobility even with while moving within the country. The country's boundaries, right, without technically having roaming. What makes things special from a technical point of view when you cross boundaries, or is it because at the IP level we don't see much mobility when we move within a country? So, for example, when I speak to my neighbor in Glasgow, our traffic goes via London. Is that the case? Do you have any insight on that?
So the why of using, so let me see if I understand. I'm just gonna project your question back at you, see if I understood what you're
Yeah.
actually asking. So you're asking like, why do we use roaming for this type of IoT solutions? Is that the question?
No, more fundamentally, what's special about roaming technically? Some of the moves you see at the IP layer, they could happen in theory even without crossing country
Right.
boundaries, right?
I mean, even within at the national level, you still have roaming, right? So in the UK, for example, when O2 was down for a week, they basically ended up using, Vodafone's network. That was roaming, right? However, at the national level, you're not going to be affected, as you said. All your traffic anyways goes, from Glasgow to London, but you're not affected. Like, you don't perceive that latency that much. It does not impact you that much. But imagine that you're now in the US and your traffic still goes through London. Like that, you pretty much will feel, right? And let's say that, okay, it's you with your mobile phone, you could purchase a SIM card in the US, right? A data SIM card from the US, but what if instead of your mobile phone, we're talking about a elevator that has entertainment in the elevator, and then all the traffic still comes from the UK? Like, that's really not okay. Okay, maybe that's not so impactful because it's just entertainment. But what if we're talking about, critical services, emergency phone calls still are pre-provisioned, because IoT verticals essentially just like IoT verticals, I mean, IoT companies, logistic tracking, shipments, international shipments, elevators I mentioned, points of sale, like the terminals that you use for paying, ATMs, security solutions for your home. All these applications just prefer to have less headaches. So they're going to go to Twilio, or they're going to go to Truephone, or they're going to go to Telefonica. They're going to say, give me SIM cards for all my devices. And I just want to place my devices worldwide. And I just want to have like one dashboard where I see all my devices, and I can just play with the data quotas, and I can just, activate and deactivate devices. And I don't need to go to each country on my own to say, you give me some SIM cards, you give me some SIM cards, because I have some devices here. So I choose this solution because from a management point of view, an operational point of view, it's simple. However, internationally, because of this tunneling of the traffic, I see issues. And in our ticketing systems, we see a lot of issues going like, it takes a while for my devices to establish communication with my data server. And we're like, hey, that's what you actually bought, because that's how the service is created. And then you're asking me, okay, can we change that? Well, the answer is no, because that's how you have billing in place. So what do you need to change? You either need to change the way, so be creative and just separate control. So if you want to have the control plane the same, you keep the control plane in the home network, and you just change the data plane. You just move around the data plane, which is what we are working on. Or you just basically break everything and you just rethink everything. And then you're saying like, why do we need to just get this IMSIs from these networks? Why do networks have this power to offer these identities that are associated always to their networks? Can we do better than that? And that basically kind of like, cascades down to different other parts like billing. Yeah.
Oh, very interesting. Thank you.
Okay. Yeah, I hope I answered your question.
Yeah, it's thought-provoking. Yes, thanks.
Sure. Any more questions?
So I was thinking about impact on the future, right? So you've got so many different IoT devices, and many of them are probably still on 2G, 3. I think I saw one slide where you said 2G, and I was like, really? Are we talking 2G still? And if they're all going back to their home countries, what does that mean for the ability of one operator, or maybe even one whole country, to completely switch off 2G or then 3G and then move onwards to 5G or whatever G happens to be at that point, right? Do I understand correctly that because of this, both the home country as well as the visiting country would need to have the same infrastructure, the same kind of signaling, same kind of control procedures.
That is actually a problem. That is correct. You correctly identify that. It was surprising to see, you know, that out of the inbound roamers in the UK, so I looked at specifically at O2 UK for a couple of years. Out of the 20% population that are inbound roamers IoT devices, about like, I would say 70% were 2G devices or devices that are communicating over 2G. And that's over O2's infrastructure. And that basically pushed back the plans for turning off 2G. Actually, I think O2 is one of the last ones. So I'm not sure if other operators are still supporting the 2G network. So that was a conversation we were having at that point. And indeed, because the lifetime of IoT devices is very long, they still need to be supported up until, so now the plans are at least until 2025, and we'll see how that progresses. But yeah, substituting the device itself is quite challenging. And especially if we're talking about like smart meters or devices that don't have any requirements in terms of large data volumes to be transferred, but just like tracking and so on, and sending maybe one measurement a day. Yeah, they're still out there, still going to be used, and putting this pressure on the whole ecosystem. And again, these protocols are like chattier, so they generate more control traffic. And again, nobody pays for this control traffic. So it's, yeah, that's an issue.
Interesting.
But yeah, more analysis in the IMC paper. I'm encouraging you to have a look at that. And also the SICOM 21 has a sort of updated view on that from the global perspective. So yeah, thanks so much.
That brings us to exactly 1700. So well done, Andra, on keeping on time exactly to the minute.
Thank you all so much.
Yeah, thank you so much for giving the talk. And I guess we'll see you all in the next NGN seminar, end of October.
Thanks for having me. Take care. Have a nice weekend, everybody. Bye.
Cheers. Cheers, everyone.
Thank you.